This is question number 6, Pathfinder, Newton's laws of motion, MCQ. A light inextensible string of length 15 meters is hanging between two pegs that are 9 meters horizontally apart as shown. So this is a light string. These are two pegs and the horizontal separation is given as 9 meters. The length of this string is given as 15 meters. A small frictionless pulley of weight supporting a block of weight is gently placed on the string and allowed to move gradually to a place on the string where it can stay in equilibrium. Radius of pulley wheel is negligible as compared to the length of the string. And which of the following conclusions can you make when the pulley is in equilibrium? Level difference is 4 meter. Tensile force depends on the level difference. Tensile force is always 8 Newton irrespective of the level difference. Length of the string segment on left and right are 10 and 5 respectively. Okay, so let's see how to tackle this question. These are the sections of strings on either side of pulley. The blue line is showing where the pulley is hung. These strings will become straight as soon as this pulley is placed here because these are light strings, so they'll straighten up. The curvature here shown in the figure is only when there is no load put on the string. When there is a load put on the string, it will straighten the two parts. So suppose the pulley system is in equilibrium at this position and the two sides of the strings become straight like this. Since the pulley is light, the tension on both sides of string will remain same. So the tension on this side will be equal to the tension on the other side. This is because the pulley is frictionless. Now, since the pulley is at equilibrium and three forces are acting on it, the tension and its weight, and it's in equilibrium, the horizontal force must be 0 as well as vertical force, net force on it must be 0. So horizontal forces will be 0 only when the inclination of these strings from horizontal, they are same. These angles will be theta each. These two angles will be same because these lines are parallel lines. And this angle, they are same because horizontal component of T has to cancel out. So the same angle theta will be formed on this side. It means the slope, the magnitude of slope of string on either sides is same. Now, if you extend this line, like this, so the same theta will be made vertically opposite here. It will be a straight line. And these two parts will be a mirror image of each other in this line, in the central line. The total length of string is 15 meter. If you mentally straighten this part, the straightened part of the string will have the same length as the length of string on this side of the pulley. So this total length is 15 meter. This is 9 meter. From Pythagoras theorem, it will come out 12 meter. From getting the vertical forces on the pulley, we have this equation 2t sine theta is 12.8. And how much is sine theta? From this triangle you can see, from this triangle, sine theta is 12 over 15. So just put the value of sine theta and solve for t. So t is coming out equal to 8. So option C is correct. The tension is 8 irrespective of the level difference. See, we have not used the levels, positions of these pegs anywhere in these calculations. So it is independent of the positions of pegs. Suppose this peg, the position of this peg is lowered a bit. So in that case, if it is lowered a bit, then the separation, the vertical separation between the pegs will increase. And the pulley will then come to a new position like this. This is extended part. The actual part of the string on this side will be the mirror image in this line, in the central line, as we have here. Since theta is still the same which we had earlier, so all these calculations will not change and T will still come out equal to 8. So tensile force is always 8, whatever the level difference of the pegs is. So option C is correct, and rest of the options are wrong. You can verify. Okay.